In this video, we are going to solve the inequality x plus 2 all to the power 4 over x cubed minus x plus 2 all squared over 2x is larger than or equal to minus x over 16. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step would be to try simplify the left side. So we can take out some common factors like x plus 2 all squared to make the remaining expression after taking the common factor not having any fractions as coefficients. I'm going to take out this over 2 as well. So divided by 2, and also I'm going to take out x cubed. So what remains will be x plus 2 all squared doubled minus x squared. So these are the terms inside the bracket, and the product is larger than or equal to minus x over 16. Then I'm going to simplify the bracket on the left, which gives 2x squared minus x squared, so that's x squared plus 4x plus 4 doubled, and that's 8x plus 8. And we can at the same time multiply both sides by 16. So for the left, we have 8 times the product, and for the right, we have only minus x. Then I'm going to move the minus x to the left as well. So now on the right, we have 0 only. Of course, we can combine the fraction and x so that it's just one fraction, but an extra plus x to the power 4 at the numerator of the fraction. Then to simplify this, I'm going to first expand x plus 2 all squared, which is easy. And now, just a tiny trick in expanding the product of x squared plus 4x plus 4 and x squared plus 8x plus 8. Indeed, I can rewrite that as x squared plus 4 times x plus 1, close bracket, times x squared plus 8 times x plus 1, close bracket, plus x to the power 4, all divided by x cubed, which is non-negative. Now, we can treat x squared as some variable, at the same time x plus 1 as another variable. So expanding will be like a quadratic with x squared all squared, so x to the power 4, and then we have 12 times x squared times x plus 1. And finally, 32 times x plus 1 all squared. And all of these multiplied by 8 plus x to the power 4, all divided by x cubed, is non-negative. Now, we have terms of x to the power 4, x squared times x plus 1, and x plus 1 all squared. So by adding the extra x to the power 4, we actually have, again, something very close to some quadratic expression, and let's see whether we can factorize it. And actually we can, because for 9x to the power 4 is 3x squared all squared, while the last term, 256 times x plus 1 all squared, is 16 times x plus 1 all squared. And the middle term will be 3x squared times 16 times x plus 1 doubled. So in fact, the numerator is actually a perfect squared. And that is 3x squared plus 16 times x plus 1 all squared, all divided by x cubed, is non-negative. and we can simplify and factorize the expression inside the perfect squared. Since 3x squared plus 16x plus 16 is 3x plus 4 times x plus 4 all squared, all divided by x cubed, is non-negative. Now, we've managed to simplify the inequality. Finally, we know that numerator is always non-negative, so as long as x cubed is positive, then we are good. So whenever x is positive, the inequality must hold. Now what about if x is 0 or when x is negative? We know that when x is 0, then the inequality is undefined because then the denominator will be 0. But when x is negative, then x cubed of course is negative. However, there are also some special cases which allows the fraction to be equal to 0, which is when 3x plus 4 or x plus 4 equals 0. And so either we have x to be positive, or if x is negative and x equals minus 4 over 3 or minus 4, the inequality will still hold because for those negative numbers, the fraction will be equal to 0. So this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.